Swayam Prabha. Digital India. Educated India.
Okay, welcome to this video lecture series on basic surveying. Presently we are talking about plane tabling, and which is in our module number 8, and today we will be in lecture number 2. This is the entire structure of the course, the full video lecture course. What we have discussed so far in plane tabling, we talked about the concept, why we need to do plane tabling. We do it for filling the details. Then we looked into some instruments, the equipments which we use in the plane tabling. Then we went into the methods. Well, we have the method of radiation, intersection, in order to plot the details. Before that, we need to set up the plane table, label it, and orient it. We have also seen the methods of orientation, how to orient the plane table. What we will do today, we'll continue further and we'll talk about one more method of plotting the details, which is called traversing. Then a very interesting concept, resection, 3-point problem. We will look into the methods, Lehmann's methods, mechanical method, Bessel's method, in order to solve 3-point problem. Then a little bit about the errors in the plane table. More importantly, if we miscenter the plane table, what is the effect of this centering error? This is what we'll talk about today. So let's begin with the method of plotting the details. We have seen 2 methods so far, like the radiation. In the case of the radiation, what we do, we take the sectors using the alidade. For example, we are standing here, I have got the plane table, and on that plane table I keep my alidade. Through the alidade I sight a particular object. I draw a line along the straight edge of the alidade. We say that as resector. Once that is done, or the ray, once that is done to the object or to the feature, we measure the distance actually on the ground, and by measuring the distance we convert it onto the scale at which we want to make the map and plot the point. So this is the method of radiation. The points are plotted. We need to measure the distances to all the points. We have seen the problem with that, and we eliminated that problem in case of intersection. In the case of intersection, we just occupied one point, took many rays to various features there, then we occupied the another point. We measure only one distance between the point which is first we occupied and the next point. We convert this distance onto the scale, and using this distance only we orient our table at the second point by backsighting. So that was the procedure for intersection, and from the second station all the resectors, they will intersect the resectors from the previous station, and those points of intersections are actually the features. So this is how we are eliminating the distance measurement on the field. However, there is some limitation. The limitation is, if for example we have a very big feature, okay, and we want to occupy one point and the second point, our plane table is here, second time it is here, and we are plotting these details by intersection, okay. So what we can do by intersection, we can plot only a little part of it. How about this part? How we are going to plot all these? Because our plane tables are only here. So this can be realized now if we replicate the same process. What we did, we occupied one point, made some resectors, then we are moving to the second point, again we are drawing some resectors, then possibly we can move to the third point, again draw some more resectors, then the fourth point, again draw the resectors. So that way what we are doing, we are rather forming a traverse. So this method of plotting is called the traversing. So we will see one example of the traversing now, how we plot in the traversing. Okay, we have taken a building here, and in this building, these are the corners. We occupy, let us say, point S1. And we have also taken a decision that after S1, I will occupy S2, then S3, and then S4. And I can complete or rather cover this entire building. We keep our plane table here. This is small S1 here. This is S1. Because my plane table is over the ground point S1, so this point is S1. Okay, now what we do from this S1, we draw resectors. Resectors means we use the alidate and start drawing the resectors. First we cite the station S4. Okay, we draw this particular point. I measure this distance. This distance is measured. Okay, because this is the distance between our main stations. So we measure this distance and then we plot this point here. So this S4 is plotted. Then next, I am drawing a resector to the corner A, then to a corner B. Right now I am not plotting this A here, okay, because I am not measuring the distance from S1 to A. Similarly, for B also, I am just drawing a resector. So I have got a resector here and here. But still we do not know where these A and B are on my sheet. This is not known to us. How we will know it? We will know it by intersection once we shift our plane table to the other station. Well, let's do it. Before doing that, of course, we will take a site to S2 also, and we will plot this S2 on my sheet here because this is my main control station. So S2 is plotted. Next, we take this plane table to S2. So if I take the plane table to S2, you remember what was there in the plane table? Right at this moment in the plane table, we have S4 plotted, S2 plotted, and this sector and this sector, these are plotted. So when we carry the table to S2, we will have all these on our table. Well, at this S2, we will orient our table by the backsighting. Backsighting means we are keeping the alidate at S2 and we are keeping it in such a way that the straight line about the straight edge of the alidate passes through S1, or the other way around, I can say we keep the alidate in such a way that its straight edge is passing through S1 and S2. Then we rotate our table at this point in such a way that S1 is bisected. Once that is done, the meaning is we have oriented our table. So the table is oriented now. Once the table is oriented, we start drawing the resectors. Okay, so resectors to B, well, this was the resector to B at S1 station, and here is the resector to B, as you can see, at S2 station. So the result of these two, the intersection, is point P. So our point B is known here. So we have plotted the point B. Next, we will take some more resectors, for example to the C, and I have got a resector now to C. Well, next to E, and then we will again take a site to the station S3 because we want to now shift our table here. Same intersection we would like to do by shifting the table to S3. Well, the table is now shifted to S3. Once the table is shifted to S3, again we will orient the table here by backsighting this S2 because S3 and S2 both are known on my table. Once the backsighting is done, the orientation is done, again the job is now to take some more sectors, for example to the F corner of the building over here, then to the E corner of the building, then to the C corner of the building. And wherever they intersect with the corresponding ones, the corresponding sectors, all these points are now being plotted. Similarly, we can take our table to S4 point, and there in the S4 point also, we start drawing the sectors. Okay, so we are drawing these sectors here now. So all the points of intersection, as we can see here now, the corresponding sectors, they intersect here. Okay, by joining all these points, what we should be able to get, we will be able to get the map of the area. So for a large building which cannot be covered from only 2 stations by intersection, we rather take a full round, we make a traverse. So this is the method of traversing. In this case, we have taken a large building, but the same thing can be applied for other cases also. For example, if there is a road, okay, we can start from a plane table here, then we move to the next point, then we move to the next point, then we move to the next point. So what we are doing actually, we are forming a traverse, and by this traverse we are also plotting the details on both the sides of the road. So these are the sectors, wherever they will intersect on the table, we can plot the road. So we can go for this traverse in different cases. Well, let's look at a new concept, and this is the concept of resection. What we know by this time, we know the methods of plotting. Now here is a very important concept which we should see. As we have discussed before also, in the case of the plane table, we have already mostly some controls available. Now what is the meaning of this? Let us say over there is a ground. In this ground, by some method, we established a set of controls. This method could be triangulation or traversing or any other method. And this set of control is plotted on our plane table. The meaning is, well, we have got these controls plotted here. Now this is the drawing sheet, and this drawing sheet is attached to the plane table. If this is A, B, C, D, E and F, the points on the ground, the corresponding points are plotted on the sheet. As we have discussed previously also, the concept of whole to part. In our concept of whole to part, what we discuss, the control network brings the skeleton of the area. Okay, the control network is done very accurately. So the skeleton of the area is fixed very accurately. Next, what we need to do, we need to fill the details. Whole to part, we want to work in the part. Well, for this, let us say this particular area has a road, or maybe a river. This is a part of a river here. These are the features. These are the features there on the ground. Or maybe some houses or whatever. Okay, maybe some trees. Now, having established this control, A, B, C, D, all that, now what we want to do on my sheet, on my plane table here, I want to plot the river. I want to plot this. I want to plot the road. I also want to plot the buildings where these are. Now the question is how to do that. There in the ground, what we have there in the ground? In the ground, if you go with this plane table, we have A, B, C, D, E and F. These are the stations. Now in my plane table, as we saw, this is the plane table, and in this plane table we don't have anything but only these locations plotted, these control network plotted. So the plane table looks like only few points plotted there. We know the corresponding points there on the ground, that this point small a is corresponding to this point. So here we know this small a is corresponding to a point there in the ground. Similarly, B, C and others. Now when we take this plane table to the field in order to plot the details, for example, let us say I am occupying somewhere here and I have got these stations plotted. In order to start plotting, as we have seen in method of radiation, let us say we want to do method of radiation. In order to start plotting, what should I do? Number one, I must orient my table. If my table is not oriented, I cannot plot, and if I plot, my map will be distorted. Number two, I must also know where I am on the plane table. Okay, what is the meaning of this? I am occupying with the plane table this point of the ground where I am standing right now. But on the plane table, we have the control network plotted. Within that control network, where I am, the idea is, if you see again here, if we are occupying this particular point here, okay, we are occupying here. Now, where I am in the plane table, am I here? Am I here? Or am I here, here, here? One thing you can guess very well, because the geometry A, B, C, D, E, F, we have this plotted here, A, B, C, D and E here and F. Okay, we have these points plotted. We are somewhere in between B, D, E, C. So we are somewhere in between B, this is B, D, E and C and E. That means we are somewhere here. But where exactly? Am I here, here, here? And these distances could be very large depending what is your scale. At what scale we are making the plot? Even this much distance could be very, very large. So I need to pinpoint my location on the plane table exactly. And this procedure in which we make use of available control points which are plotted on the sheet as well as which are there in the ground in order to locate where I am on my plane table is called resection. So this is the resection, because we need to do it once we locate ourselves. Okay, yes, we take a decision here now. The decision is, fine, I have found somehow whatever the method that I am here. Then I can start plotting. Because if I am here, my table is oriented, I can start plotting that little house or the river or the road network by drawing the radiators or the resectors and measuring the distances. So resection is very, very important thing. Now we have seen this, that the plotting will be followed by orientation and resection. We are looking into now how to handle this problem. Okay, if we have 3 points known, this problem of resection is called 3-point problem. Why it is called 3-point problem? Let us say there in the ground we have 2 points, first A and the another one is B. These are the 2 points. Okay, and these 2 points are also plotted on my sheet, A and B. Now we want to determine, because if we are occupying somewhere here with this plane table, A and B plotted on the plane table, and these are the points on ground. These could be the corners of the building, some trees, some triangulation stations, whatever, this capital A and capital B. This is our drawing sheet or the plane table. Now I want to know where I am. Well, approximately we can guess we are somewhere here. But where exactly? If I can measure somehow the distance from A to this point and capital B to this point, okay, I can take the arcs in order to locate myself. What is the meaning of this? if I can measure this distance and this distance, I will convert these to the scale. If this point is capital P, so small PA is capital PA multiplied by the scale. Okay, so this small PA, I will take an arc here. Similarly, with small PB, I will take another arc. So we can locate this point, small p. Yes, we should be here. But at the same time, these arcs will also cut here. Okay. So which of these two solutions is possible? Or which one is correct? So in order to avoid this condition, what we do, we take rather a third point also. This is C. And we measure the distance CP also. And we convert it by multiplying by the scale into small c, small p. So from a third point also, which is small c, we take another arc. So that fixes our point. Well, we are definitely on this point. So this is method of resection, and this is why we need 3 points for a unique solution. Now how we do it? We don't do it by measuring the distances. You know, in the ground, it may not be always possible for you to measure these distances. These distances could be of order of 5 kilometers, 2 kilometers. It's not always possible to measure these distances. We are looking for some method in which we can do it and the solution is also feasible in the field. What the solution could be? Well, let's look at that solution now of that 3-point problem. To solve this 3-point problem, the very first method that we'll discuss is tracing paper method. What we do in this method, let us say there are 3 points, and this, whenever I am saying capital letters, you know, these points are there in the field. These may be the triangulation stations, or these may be the corners of the buildings, these may be the electrical poles, or these may be, you know, some telephone poles, some permanent features which we observed as the control point. Okay, so these are the control points, is A, B, and C. As well as we know, this control point is also plotted on our sheet, small a, small b, and small c. So they are plotted on our sheet also. What we are looking for? We are looking for to orient our table. Right now you will observe that the table is not oriented because this AC line is not parallel to the AC line. These two are not parallel. So we are looking to orient this table. Once our table is oriented, we can determine very well where we are just by drawing some sectors. Well, let's do it now. In this particular method, the tracing paper method, we make use of a tracing paper and we put it on top of the plane table. Now, under the tracing paper, we have these points A, B, and C plotted on the plane table. Now, we choose any other point on the tracing paper. So, this small p is marked on the plane table. And what we do, from this small p, without having any concern for these points at the moment, we draw resectors to A, to B, and to C. This is very important. What we are trying to realize here? See, we have now 3 resectors to A and B, B and C. So somehow I have found alpha and beta angles between these sectors. Now one thing very important here. See, we are where our position should be. If we are occupying with reference to these A, B, and C, if my plane table is here, so on my sheet with reference to A, B, and C, I should be somewhere here. Okay, so on my sheet I should be somewhere here, and if my actual location is this, you know, as we know, if my plane table is oriented corresponding to A, B, and C, I have small a, small b, and small c, and that's the point P where I am. Now this angle is alpha, this angle is beta. Now one thing which is very important here in the tracing paper method, what we did in the tracing paper method, as you can see, we put a tracing paper here. That was our sheet which is not oriented, or the plane table. We put the tracing paper here, and on tracing paper we started drawing those sectors. And what we are getting here, we are getting these three lines, and the angle between these three is alpha and beta, and this alpha and beta are same as the alpha and beta here. Now why it is so? Because the distance from plane table to those points, control points, is very large. A little bit shift here, it is not going to matter much. So the alpha and beta, wherever I do on the plane table, alpha and beta will be nearly those values which are same as the actual alpha and beta. So by doing this, we have realized these two horizontal angles. Next, what we do, I'm showing it here, but in fact we do this particular procedure over here also only. We don't do it here, but in order to show the procedure, I'm just taking it here. Otherwise this procedure is done on this point only. Well, this alpha and beta and these resectors, this is the resector to A, to B and to C. Right now these three lines are drawn on the tracing paper. Okay, so what we can do now, we can shift the tracing paper here and there, as well as rotate it in such a way that these three resectors, they pass through their corresponding points on the plane table. Let us do it. We are doing it here. Please look at carefully. We just shift here in this case. Okay, this could be also rotation. We rotate our tracing sheet, or we shift it here and there in such a way that these three sectors, the resector here, here and here, they pass through their corresponding points. This point is A, this point is B and this point is C, which are plotted on the sheet. So just by shifting, it was achieved in this case. Well, what we have realized now, this point P with reference to this A, B, C, where it should be? It should be at this point. Now, what we will do, this point small p is still marked on the tracing paper. So we will prick this point down on the sheet. So by pricking it, we will mark that point on the sheet and we will remove the tracing paper. So what we have got at this moment? We have got now A, B and C, which were already plotted on the sheet, and this point P, which we have now found. So basically, what is this P? This small p. This small p is the location of plane table with reference to our control. It should be here. So with reference to our control, the plane table is located at this small p. That is what the meaning of this. Well, once we have found this small p, what to do next? Well, in the next case, let us say we bring this table, because we had seen here also, as I was telling you, we do this particular procedure over here only. Alright. So what we have found, we have now A, B, C and this small p located. We keep the alley date, this is the alley date here, we keep the alley date along PA. This is the point small p, small a, and this will not pass through A, capital A there in the ground, because my table is not oriented. So what we do next? In order to orient our table, we will have to rotate our table. So we rotate our table now. So by this rotation, we will ensure that our resector is passing through A. At that point, my table is oriented. In order to check it, what we can do? We can again keep our alidade along small p and small b, and we will check that the resector should pass through B, as well as small p and small c, the resector should pass through C. So at this point we know where we are, small p, as well as our table is oriented. So the meaning is we are ready to plot. We can start plotting from this point now. Using this P, I can plot the various details by taking the resectors or by any method, by measuring the distances and plotting the things. So this is the tracing paper method of solving 3-point problem. Okay, are there any problems with the tracing paper method? Yes, it is difficult to work in the field, there may be the winds in the field. So working with the tracing paper, putting it there, drawing the lines and rotating that, again it's a kind of trial and error, number one. Then there may be problem because the wind, the tracing paper may go here and there, and we have to look for a solution which you can work with in the field. Can there be a solution which is different than this one? We have one more very good solution, which we say the Bessel's method. Now in this particular method, again we have now 3 control points there on the ground, A, B and C. These 3 control points are plotted on my sheet. This is A, B and C. They are plotted on the sheet. At the moment, my sheet is not oriented. Okay, the sheet is not oriented. As you can see, in order to do this Bessel's method, what we do, we follow some steps, and please follow these steps carefully. We are going to list those steps here. You can find these steps also in any of the textbooks, but following those steps carefully is very important, number one. Number two, to understand, as we knew the concept, what we are doing in the tracing paper method. In tracing paper method, we are trying to realize the horizontal angles which were being formed by those control points at the point where we are standing. Somehow we found those angles, and then on my sheet, by shifting the tracing paper here and there, we found that small p, because small p should satisfy those angle conditions. So we know the concept there. Now here we'll follow the steps, but again it is important to understand the concept of the method. This method is also based on the same concept of the angles, alpha and beta, as you will see now. So the very first step here is we place alidade at BA. Okay, the alidade is placed on BA. BA is here, small b and small a. After placing the alidade on BA, we rotate the table to site A. So what is the meaning of this? That means your eye is here and you are looking in this direction. Okay, now you rotate the table so that A can be bisected. Well, let's do it. If you rotate the table so that A is bisected, well, that's the condition. Well, here in this case, as you will see, A is being bisected by the resector, because our eye is now here. We are looking in this direction. Once this is done, we clamp the table. The next step is clamping the table. The table is clamped. After clamping the table, we rotate the alidade about B to site C. Well, we rotate the alidade over here. The alidade is rotated so that you can sight C. Let's do it. Well, this is how it has been realized. And we draw a line, and that line we say XY. So in that condition, once this C was being bisected, by keeping the alidade at small b, we have drawn this line XY. Next, we are repeating in similar steps. But now what we are doing? We are keeping the alidade along AB. We are keeping at A and at B. So our eye is like this here. Okay, and we are looking along this line. and we rotate this alidate, or rather we unclamp the table, and now we rotate the table along with the alidate. Okay, the table is being rotated along with the alidate so that B is bisected. Well, let us do that. If we do it, the table will rotate like this and the B is being bisected. Again we clamp the table. So the table is clamped now. Next step, we keep the alidate at A to bisect C. Capital C means there on the ground. So we keep it at A and we bisect capital C. So now we are looking like this. The table is clamped. The table is not moving. In order to bisect, earlier the alidate was along AB. Now we have to rotate the alidate so that it bisects C. So table is clamped and we rotate the alidate to bisect C. Well, the C is bisected. Now the intersection of XY and this resector, it gives us a point C dash. Okay, that point is C dash. So once we have this point C dash, we keep the alidate along C dash C. C dash C means C dash C. So we keep the alidate like this, and now again we unclamp the table, because we have to follow these steps very carefully. We are unclamping the table now, keeping the alidate along C dash C. Now you rotate the entire table. Well, let's rotate the entire table now here. If you rotate the entire table, keeping the alidate along C dash C in order to bisect C. So what we will have? We will have alidate along C dash C, and we are bisecting capital C there on the field. At this stage again, we clamp the table. If we have performed all these steps, what we will find, what we will notice? At this stage, the table is oriented. So this is really interesting. How by following these steps, the table gets oriented? If you get into this method, you will realize that basically again the same alpha and beta angle. We are playing with those angles. We are generating those angles here also. And somehow, as in the condition of the tracing paper method, we are doing something similar to that by following these steps, but it's not trial and error. We have our table oriented here. Once the table is oriented, what we have now our oriented table as well as small a, b and c, which are already plotted there. Now the question is, where am I? The table is oriented, we have clamped the table and table is kept at capital P. We want to determine this small p on the table. Where am I? Well, I understand I should be somewhere here. The where exactly? Now in order to handle this problem, in order to answer this problem, we already have the concepts. If you just think of the method of radiation, in that we knew small p and we found the small a, small b and small c by drawing those sectors. Okay, here in this case the table is oriented. I know small a, small b and small c on the sheet. I know the corresponding capital A, capital B and capital C there on the ground, and now I want to determine the small p. Okay, so the job is very easy. How? We keep the alidate at small b on the drawing sheet, okay, at a small b, and I rotate the alidate till the corresponding point there on the ground, capital B, is bisected. And then I draw the resector. Well, the resector is drawn here. That's the resector. Second, I keep the alidate at small c. I can do it for A also. At a small c, rotate the alidate now. Table is not being rotated because table is oriented, is clamped. I only rotate the alidate so that capital C there on the ground is bisected. I draw a resector. Let's do it. Now here I am citing C, drawing a resector. So we get a point of intersection here. Obviously, as we understand, this point of intersection is the point where we are, which we say as small p. So we have, our orientation was already done by Bessel's method, and as well as now we know where is small p. So we know this particular point also. Once we know this, our job is done. We can now start plotting the various features. Okay, because we need to know where this point is in order to start our plotting. Well, there is one more method, which is the Lehman's method. Again, it is trial and error method. What we do in this method, same thing, 3 points there on the field, which are the control points. We know their location. You know, this capital A, capital B and capital C, which I am showing you, could be anything. The condition here is we should be able to locate them. You carry your plane table, put it there, and then we look around for the control features, which are also plotted on the plane table. Having located those, then we start this process of 3-point problem. We solve the 3-point problem in order to two things: orient our table as well as find where we are. Now in this method, the Lehman's method, how we go about? Well, this is our table, let us say. Our table is kept at a certain point, somewhere. We want to do two things. Number one, we want to orient, and number two, we want to resect. Means we want to determine that small p where it is. Now how we do that? In this method, first of all, we put our alidate along small a. Okay, that's the point small a here. The point which is plotted on the sheet. This is small b and small c. And the alidate is kept on small a. Now I bisect the corresponding point on the field. Table is clamped. Table is not moving. I rotate the alidate in order to bisect capital A. Let's do it. Okay, it is bisected, and I draw a resector. Well, the resector is drawn here now. Similarly, I do for B, I do it for C also. Well, before I do it for C, if these three resectors, they intersect, they will definitely intersect here somewhere. If, how they will intersect? Right now my table is not oriented. Again, go back to the concept of radiation method. You know, if my table is slightly disoriented, in the case of the radiation method, think of that method. What will happen? These resectors will now form a triangle. They will not cut at a single point. So this is what which will happen here. Okay, that we can see here. Here is the triangle of error. This triangle we say triangle of error, which is formed here. If these three resectors, they meet at a single point, okay, resector to A, B and C, then there is no problem. The table is oriented, as well as this point is our small p point, the p where we have occupied. But this is not the case here. In this case, they are forming a triangle of error. So what our effort will be now? We will, this is our first approximation. Well, our point has to be somewhere over here. Where it is? This is what we have to do. It is somewhere around. That's our first approximation. For the second approximation, we'll do the iteration. So this is why this is, trial and error method. We try to reduce the error. Well, in this case, the error means this triangle of error. How we do that? Well, in order to reduce that, the next step is we locate an area where this point will be. Now, how this area will be located? It's very easy. If we are occupying somewhere in between, let's say these are the control points A, B and C, these are the control points, and our triangle is being formed here like this. This is the triangle of error. It's very, we can understand it, or it's very obvious, because we are inside the great triangle. We say this is as great triangle, which we are using for our resection. Our point P will be also inside the triangle of error. Now there are some rules of this Lehman's method, we follow those rules. Number one rule says this thing only. If we are inside the great triangle, our point P, small p, will be inside the triangle of error. If we are outside the great triangle, as in the case which we are doing here, over here, because we are outside the great triangle, definitely our point has to be also, small p has to be outside this triangle of error. Number one. Number two, the resector are like this. The second rule says we have to select next approximate position of this small p in such a way that it is either on left or on right side of all the resectors. Here we are selecting towards the left. Left means it is left of this resector, so this full area. Okay, anywhere here. Left of this resector, so this total area. Left of this resector also. If we consider all these and left of all these, what we end up with? We end up with, well, our point has to be somewhere in this, because this is outside the triangle of error. It is towards the left of all the resectors. Okay, so our point has to be here. That's the second rule. And then the rule number 3, it says our points should be selected in such a way, because I can find a point, I can keep it here, keep it here, keep it here, anywhere in this area, but the next point has to be such that it is as nearer as possible to the triangle of error. At the same time, the point should be located in such a way that the distance of the point from the resectors, for example, this is the resector to A, and that's the distance, small p h. So this small p h, it should be proportional to p a. What is the meaning of this? The meaning is the point where we are occupying is capital P. So the distance from A to P, we can have an idea of this distance. We need not to measure it in order to solve this method, but just an approximate idea of this. So the point P will be in ratio, the distance of this should be proportional to the distance here from resector to B, again proportional to the distance here from resector to C. This distance P, and let's say this is H C. So P H C, this should be proportional to the P C. So we have to find the distances in these ratios, in the ratio of the distance of table from the points there on the ground. Well, having done that, we will locate the small p. Well, let's locate it. So the small p, we say find. Let's say it is here. We have found it. So this is our next approximation or the estimated position. Once we have found it, we say this is, we are more nearer to our solution, but still we are not in the solution. What we do next? We keep our validate along this small p and let's say A. We keep it like this. Okay. Now if I keep it like this, and will it bisect A? Right now it will not bisect A. No, because this is a different point. I rotate my table now so that it will bisect that. So the table is rotated now. If you rotate it, let me remove this now, and I rotate it. If I rotate it, A will be bisected. Now this is the next approximate orientation of the table, or rather the better one than the previous one. Similarly, I draw the resectors from B and to C, and I again find a triangle of error. So the triangle of error in this case is smaller. The meaning is we are approaching the solution. So this is the triangle of error, and again, as per the rules which we discussed previously, we can now again find a new location of a small p, another approximation. Okay, we are more nearer to the solution, we find that small p again, and then we keep repeating this particular process till this triangle of error, it becomes a point or very nearer to a point. So this is where we have now, what all we have achieved in this case. Once this triangle of error, it becomes a point or very small. This point is small p, as well as our table is also oriented. So we have found our solution. The solution of the, we have done the orientation resection. Now we are ready to plot. Okay, so we have seen now some methods using which we can do the resection. Resection means, we are doing the orientation as well as finding where we are on the plane table. Now this method will fail, all of these will fail, provided, as we can see here, if this is our A, B and C, the points there in the ground, okay? If the point where we are occupying is in this circumcircle, passing through these three control points, then this method fails or it becomes indeterminate. Why? Because right now, as in all the methods, we have relied on alpha and beta. Okay? In this case, if we are on the circumcircle, wherever you are standing, okay, if you are standing here also, still the angle is alpha and beta. So wherever we go around, we will find a solution. So because of that, the solution becomes indeterminate. So we should try to avoid this kind of condition. Okay. Next, let's look into the error in the plane tabling. Okay, the very first error is non-horizontality of the board. What is the meaning of that? We say, well, our table should be horizontal. If it is not, what will happen? If the table is not horizontal, it is inclined. If it is horizontal, the basic thing of the plane table is we are, by drawing the resectors, measuring the horizontal angles. But the moment our table is inclined, now the angles which are being mapped on the plane table are being mapped on an inclined plane, not on the horizontal plane. So they are the wrong angles. What it will lead to? It will lead to distortion in the map. Okay. So similarly, over here my table is horizontal. I have done the plotting. The next time I am taking the table to some other place, my table is not horizontal there. So these two maps, they will not be compatible. One very interesting thing about plane table is, as we discussed, for a large area, if it is an area of 2 km by 2 km, let us say, we had that control point. Alright. Now using this control point, now you are going there in the field with the plane table. What we can do, we can send different people with the plane table. Let's say this is one party. Over here, there is another party. And over here, there is one more party. And all these parties are using the same control. Okay, they are also using the same control. They are plotting the local details. This party is also using the same control, plotting the local details. This party is also using the same control setup, plotting the local details. What we should be able to do, we can put all these maps together and make the mosaic, make the complete map. And all these maps, if the same control has been used, the details should match. If my table is, horizontal here, not horizontal here, or different leveling here, the details will not match. There will be distortion in the plane table, or sorry, in the map. Well, the next error is centering error. We'll try to understand what it is and what is its effect. Now what it is, let's look here. If we wanted to put our plane table over a point P on the ground, and if this corresponding P, small p on the table and the point on the ground, if they are along the same line, our table is correctly centered. However, if this small p is over some other point P dash, it should have been over P, but it has been shifted. So we say miscentering error, or the table has been miscentered. Now what is the effect of this? What we are doing here, we are plotting the points. Okay, so in this case a point A will be plotted here, while here if the table is miscentered, the same point A will be plotted at a location A dash. Let us look at the same thing. Over here, this is the first position. There is no miscentering error in this case. Small p is above capital P, and this is where this A is being plotted. Okay. In the second case, if there is an error of E, now this table is over a point P dash. In this case, if we do the plotting, we'll plot using this resector, and the point will be plotted at A dash. Now, what is the error? In order to know the amount of the error in plotting, how much this small a has moved from its position. In order to know that, we draw a line parallel to this here. Okay, so the a was here, it has shifted to A dash. So this small e is the amount of the error in plotting. How much is the value of this? So using the triangle P A dash A, we can write the relationship here. Okay. Now, what we can do, because we know small pa is derived from ground distance by multiplying it by the scale. Similarly, for P dash A, it is derived like this. So we can write further this way. Now here in this case, if you look at this, this is nothing but the value of E, because the angle theta here and here is same. So what we can write it further? We can write it as error in plotting A dash, how much the point has shifted, is equal to scale multiplied by this shift or the miscentering error. Now what is the implication of this? The implication of this, as we can see here, what is saying? This A could be at any distance, it doesn't matter. This A could be at any orientation, it doesn't matter. The plotting accuracy or the error in plotting. Error in plotting A dash is always same, and the value is S into E. It depends upon how much the miscentering error is and what is the scale of plot, nothing else. Okay, so this is very different from the centering of theodolite. Well, if our plotting accuracy of the map is 0.25 mm, we take it like that. 0.25 mm is the plotting accuracy. How much miscentering is possible within that plotting accuracy? The plotting accuracy means, a dot here. If this dot is 0.25 mm, the minimum which we can plot, well, we cannot measure within this dot. So whatever the error we do in ground corresponding to this dot is not a problem. So corresponding to this permissible plotting error, if you are working at a scale of 50,000, we find the value of permissible centering error is 12.5 meter. So if you are working at 1:50,000 scale, you can miscenter your plane table by 12 meters, no problem. Still you are plotting within the plotting accuracy. So what we have seen now, we have seen about some methods of orientation, resection, okay, how to solve the 3-point problem. What is the effect of errors, particularly this centering error? So here we close this plane tabling. Thank you.